myself Ashok Ghadge, and I am from Mankur Chita Camp, Shahjanagar BMC English Secondary School. Today we are going to see the lesson number 12, part 3. Before going to the today's lecture, we will first revise shortly the previous topics. And previously we have seen how sound is produced. The sound is produced due to the vibrations of an object, and how sound is propagated in the medium. In different medium, sound is propagated in the form of compression, rarefaction, compression, rarefaction, compression, rarefaction, and it is reaching the particular all the direction. It can be reached to the all the directions. Now, the place of higher density of that medium is called as a compression, and place of lower density is called as a rarefaction. So the next we have seen the types of waves, that is longitudinal waves, the type of waves in which the particles of that medium, whether that medium is water, whether that medium is gas, whether that medium is solid, in each medium, the waves, the particles of that medium oscillates about their central or the mean position, and that oscillation is parallel to the propagation of that sound waves. So it is called as the longitudinal waves. And the next type was transverse waves, the type of waves in which the particles of medium oscillate about their central position, and that oscillation is totally perpendicular to the propagation of the sound waves. So that is called transverse waves. So, and next we have seen different terms for first term was the wavelength of sound. You can see the figure in which the source of sound creating a wave in the form of ridges and grooves, and between two successive ridges, if we calculate, that will be the ulta y, that is lambda, and that is called as a wavelength of sound. And the next concept was frequency of sound waves. So you can see the frequency like this. If sound waves are created multiple times, there is a ridges and furrows, ridges and grooves, you can see the frequency is more. If this number is less, it will, the frequency will be less. Okay. Next concept we have seen the amplitude, the value of the length of that ridge, that is the sound source of sound, and the length of that ridge or the length of that furrow, it will be calculated as an amplitude, and it will decide the loudness. Next, the frequency will tell you the pitch, the time period, the time which is calculated, and we have seen the frequency will tell you the pitch, and the loudness will be calculated as per the amplitude. You can see amplifier. So to create a loud music, we use amplifier. So amplifier is increasing the length of amplitude, that is capital A. You can see this amplitude, the length of amplitude, if we increase, there is an increase in loudness. So the velocity of sound is equal to frequency into wavelength. This was the formula we have seen previously. Next was we saw the effect of atmospheric conditions, the physical states on the velocity of sound. We have seen the temperature. The temperature is directly proportional. The velocity of sound is directly proportional to the square root of temperature. So we have seen direct proportion and inverse proportion. And the velocity of sound, if velocity of sound, I have to increase the sound velocity, the temperature should be increased. If we increase temperature, the velocity of sound will increase. The next, if we increase density, the velocity of sound will decrease, because velocity of sound is inversely proportional to the square root of the density. Next, we have seen the molecular weight. If we increase molecular weight, there will be decrease in velocity of sound. Therefore, the velocity of sound is inversely proportional to the square root of molecular weight. If we increase the molecular weight 4 times, there will be decrease in the velocity of sound by half. Next, we have seen the reflection of sound follows the rules which are we studied in lesson number 11, that is uh, light waves, the incident ray and the reflected ray, which are equal to the normal, and the incident ray normal and incident ray, if the incident ray is falling on this surface and we draw the normal here, the angle made by incident ray, that is angle I, and angle R, that is reflected ray, that angle I is equal to angle R. So that was the first rule, and it is applicable here also. The second rule was incident ray, reflected ray and the normal both are in the same place. So next, we have seen the good or the bad reflectors of the sound. So the hard and the flat surface will be the good reflector. The curtains, which are the curtains and sofa and all other things which absorb the sound, which will be the bad reflectors. The surface which absorb the sound instead of reflecting the sound is called the bad reflector. Next, we have seen the types of sound, that is audible sound, infrasound, ultrasound. If we remember the audible sound, the range of audible sound is 20 to 20,000 hertz, and that is our range of our ear. Below 20 hertz, there is a term which is called as the infrasound. Below 20 hertz, the sound is called as the infrasound, and above 20,000 hertz, that is 20 kilohertz, the sound is called as the ultrasound. Then we have seen that is the frequency of audible sound is 20 to 20,000 hertz, and the frequency of infrasound is 20 hertz, and the frequency greater than 20 kilohertz or the 20,000 hertz will be called as an ultrasound. So today we are going to see first point, that is echo. What is echo? Then second point we are going to see is reverberation, and the third point will be sonar. Fourth point will be sonography. So in all these, there is a use of different sounds. Echo, if you shout loudly at such a point, you hear a same sound just after a little while, and this sound is called as a echo. You have also experience in a blank room, where empty room in which there is no structure, no furniture is there, no one is there, and in that room you have heard your voice multiplying and coming back to your ears. So that is called as a echo, but we can't hear that no, that voice in our normal room. So we will find out why and how this echo is generated, and why we are not listening that echo in our normal room. So the defining the echo is the repetition of original sound because of the reflection by some surfaces. So now there is also a reflection, but that reflection is not satisfying some conditions to form echo. Therefore, there is a no formation of echo. So for that, there is a beautiful video I have collected. See this.
So the voice is not audible of the video.
Audible nahi hai?
नहीं है.
Just a second. Okay, now mm, now you can enjoy that video. Okay.
Topic.
Is this audible?
Now, why do we hear echoes?
Yes,
Okay.
yes.
आवाज आ रहा है? Hello.
नहीं sir.
Hey, hold on. Don't go into
Yes
that.
sir. Yes sir. Audible.
Not to listen to me. Okay, then go ahead. See, I warned you. Will you listen to me now? Don't worry. The sound you heard was just an echo of your voice. Let me explain what an echo is. When we speak or laugh in a big empty hall, we hear our own sound repeatedly. This is because our sound waves get reflected from the walls of the hall back to us. The reflected sound that we hear is called an echo. Hence, an echo is defined as the repetition of sound caused by the reflection of sound waves from a hard surface back to the listener. Hey, what are you doing? Are you trying to hear an echo? It is not that easy. There are two ideal conditions for an echo to be heard. When we speak or laugh, we hear our original sound at that moment. The sensation of this original sound remains in our brain till 0.1 seconds. This time is called the persistence of hearing. When we utter sounds, some of our sound waves get reflected while some get absorbed. If the reflected sound waves reach our ears before the completion of 0.1 seconds, then our brain does not perceive the original and reflected sounds as separate sounds. They are interpreted as one sound. Therefore, in order to hear two distinct sounds or an echo, the time gap between the original sound and the reflected sound or echo should be at least zero point 0.1 seconds. This is the first condition for an echo to be heard. Do you know when the time gap will be more than 0.1 seconds? This gets us to the second condition for an echo. The minimum distance between the speaker and the reflecting surface should be at least 17.2 meters. When the distance is 17.2 meters and we start speaking, assume that the original sound reaches our ears at this time and the reflected sound reaches our ears at this time, then the time interval between the reflected sound and the original sound will be equal to 0.1 seconds. As a result, we will be able to hear an echo. All right, now let us try and hear an echo in this room. It is even bigger than the previous room. Now, why can't we hear an echo? This is because there are many soft furnishings like sofas, carpets, curtains, etc. in this room. They absorb most of the sound waves. As the sound waves do not get reflected, we are not able to hear an echo in this room. Hence, one more thing to consider if we want to hear an echo is that there should be minimal use of such sound absorbing materials. Hooray!
What your favorite Pokemon? Only on the all-new Vu.
Okay, I think all of you have enjoyed the formation of echo and which are the conditions. We will go into detail now. So, the echo is the repetition of the original sound because of the reflection by some surface. If some surface is reflecting, that surface will reflect that sound, the original sound, and that will be heard by our ears. Now, we will see the exact mechanism to produce the echo. How echo will be formed? The temperature, the ideal temperature will be 22 degrees Celsius. In order to able to hear a original sound and its reflection distinctly at 22 degrees Celsius, what must be the minimum distance between the sound and the source of sound and the reflecting surface? That was the first question. So at 22 degrees Celsius, the velocity of sound is 344 meter per second. That is the velocity of sound in air, 344 meter per second. So our brain retains a sound for 0.1 second. So any sound which is retained by our brain is the timing is 0.1 second. So now calculating those, the thus for us to able to hear a distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and come back to us. So the timing is 0.1 second, and the velocity of sound in air is 344 meter per second. Now we will calculate and establish the distance between them. Thus, we can determine the minimum distance between the source and the reflecting surface by observing frequency sound into timing. So 344 meter per second into 0.1 second, that is the time to retain the persistence of sound. So it is calculated and it is showed that 34.4 meter will be the distance between source and the reflecting surface in which sound will go and return back to the hearing. So if we want to hear a distinct echo, the reflecting surface should be at the minimum distance of half of the above. That is 34.4 will be the distance in which the sound will travel from the source to the reflecting surface, that is 17.2 meter, and again from reflecting surface to the ears, that will be the 34.4 meter distance between the reflecting surface and the source. So if we make it half, that is 17.2 meters, that will be the minimum distance we have to keep between the reflecting surface and our voice, so that we can see our voice to be forming echo. So as the velocity of sound depends on the temperature of air, the distance depends on the temperature. So we have seen in previous lectures that if we increase temperature, the velocity of sound will increase. So it is temperature is directly proportional to the velocity of sound. So in hot temperature the 17.2 meter will be less, and in cold temperature that may be more more distance. The distance, minimum distance we are getting 17.2 meter, will be totally dependent on temperature of atmosphere. Because if we increase the temperature, if we increase temperature, there will be increase in velocity of sound, so the distance will be decrease. Okay. For that, in hot region, that 17.2 maybe 16.6 16 15 depending upon the temperature, and in colder region depending on upon the temperature, that 17.2 may increase. So the next concept we are going to see is reverberation. So now in reverberation the concept is very clear, and I think you all have heard and experienced this reverberation in your home and anywhere. Okay, the sound waves getting reflected from the walls, roof of room, and either sound is multiplying various times. So this causes a single sound to be heard not once but continuously. So this is called as a reverberation. To clear the concept, the time between the successive reflections of the particular sound waves reaching us becomes smaller, and the reflected sound get mixed up and the producing the continuous sound of increased loudness, which we cannot be dissipated clearly. So before before clearing this, I will first give you that example. There is a singer sitting here and there is a listener sitting here. Singer is singing a song. That song is heard directly by the listener. Singer to listener, direct listening is there, but with this there is indirect listening is also there, and voice is coming back to that listener multiple times. The first sound was going, then second sound, third sound, fourth sound of same one sound is coming to that listener, and it is mixing up, and there is a creation of noise, and it will increase only a loudness, it will only increase the amplitude, it will only increase the amplitude of one voice. So the clear voice we can't hear. Therefore, that is called as a reverberation. The time between two successive reflections of a particular sound waves becomes smaller, and the reflected sound mixing up to produce a continuous sound of increased loudness. And from those two we can't hear clearly the what is exactly the word. So that is called as a reverberation. Now we are going to see the next technique, that is sonar. It is also used in uh, various fields, navigation, or navy, army, air force. That sonar is used. It is simply a technique of sound navigation and ranging. The short form of sonar is full form of sonar is sound navigation and ranging, and it is used to determine the underwater object with the help of ultrasonic sound. That word is important, ultrasonic sound. The frequency of ultrasonic sound is 20,000 hertz, greater than 20,000 hertz, or 20 kilohertz, greater than 20 kilohertz. You can see both way. So this is the shape, and there is observation of underwater object with the help of sound. So the direction of underwater object, distance of underwater object, and the speed of underwater object can be calculated and can be sensed, can be interpreted with the help of this sonar technique. In this sonar technique, there are two main objects, there are two main instruments. First is transmitted. Transmitter is used to produce ultrasonic sound waves and to transfer that ultrasonic sounds in the water. Then that sound which is transmitted will strike on the object which is beneath the water, beneath that below that ship. And if there is a object, that object, from that object surface, the sound waves, the ultrasonic sound waves will travel back, and it will be received by a receiver, which is the second instrument of sonar. And that receiver will calculate the time, what is the speed of sound in water, and that calculation will create an image, and that image will tell whether that object is coming towards us, whether that object is at the same position, whether that object is having some other instrument. Everything can be detected, everything can be visualized with the help of this ultrasonic sounds. There is fantastic video.
Sonar. Sonar stands for Sound Navigation and Ranging. It is a device which uses ultrasonic waves to measure the distance, direction, and speed of underwater objects and helps mariners to investigate the nature, size, and location of the object so that potential threat to the vessel is identified and overcome. How does it work? Sonar has a transmitter and a receiver which are installed at the bottom of the ship. The ultrasonic waves transmitted by transmitter travel underwater and get reflected back from obstacles. The detector receives the signal and converts it to electric signal. A computer forms image of the obstacle and displays it on a monitor. It also calculates distance of the object using this formula. Distance is equal to speed into time upon 2. Speed is equal to speed of sound in saline water equal to 1530 meters per second. This method is called echo ranging. The sonar technique is installed in every ship to determine the depth of the sea and to locate underwater hills, valleys, submarines, icebergs, and sunken ships, etc., to avoid a disaster.
Okay, so that was the sonar, and now we will see the detailed working of that sonar. The transmitter, which is producing and transmitting the ultrasonic sound waves. So these waves will travel through the saline water or any water. It will strike on underwater objects or the different obstacles and get reflected from them. The reflected waves will be again received by a receiver on our ship, and that receiver will convert that ultrasonic sound into electrical signals, and those signals will create a proper interpretation, and it will create a proper map so that we can get a fantastic image of that object, and we will see whether that object is underwater hill or any other thread. The time difference between the transmission and reception will be noted, and that will tell the time, and the velocity of sound in the water will give the distance from the ship of the object which reflects the wave. So the sonar is used to determine the depth of the sea. It can be used for depth of the sea, and it is also used for underwater hills, valleys, submarines. If we saw the movie Ghazi Attack, you can see there the submarines and how sonar is acting on, how sonar is used for this calculating whether submarine is near or not. The icebergs can be calculated, the distance of icebergs, sunken ships we can notice. So the next concept is sonography. Most of the people, most of the students, I think, aware of this sonography. Though if your home, in your home, your sister, uh, your any person who is married will have baby, and that person will go to the see the sonography report, and what exactly happens in that sonography report, and how that picture of baby is calculated, and whether it is only related to that pregnant lady or is it related to someone else. Can we do sonography for other purposes? There are many questions if in your mind. So we I will try to solve those all questions. So the sonography technique is also using a same ultrasonic sound waves to generate image of internal organs of the human body. Any human body, any internal organ, and any deformity between that organ, the sonography will detect. Oh, not only the pregnant lady. So keep in mind, and this is used to find the cases causes of swelling, infection, pain. So this is the sonography machine, and the condition of heart, the state of heart after a heart attack, as well as the growth of fetus inside the womb of pregnant woman are also studied using this technique. So there is again one short video.
I'm going to show you the standard ultrasound evaluation of the liver. For
Liver.
that, I will ask the patient if he has eaten.
I ate 2 hours ago.
I will use some ultrasound gel on the right epigastrium
That is the
and
gel.
use the curved array sonographical probe.
He is having a probe. So that probe will do the function of transmitter as well as the function of receiver.
The standard abdominal pre-settings of your sonographical machine will be sufficient. First of all, I go into the median of the body, into the right epigastrium, and I'll tell the patient to take a deep breath and hold it. Here you can see that I'm going through a cross section of the left liver lobe. When I've done that, I will ask the patient to exhale, then inhale again and hold it. Go to the right epigastrium and can evaluate the right liver lobe. Sometimes it's not very easy to fill in all of the blank parts of the right liver lobe because of the air that is in the colon and the patient has eaten 2 hours ago. So you can also put the right arm over your head, take a deep breath again, and here you can see the picture getting a little bit better. But still, it's not optimal. Can you turn around left side a little bit? Yeah, that's good. Take a deep breath again.
Okay. So like this, you can use this sonography for many other purposes to see our internal organs. If you have any problem in our internal body parts, you can see through this sonography. Okay, my one suggestion is there. uh, I think most of the students will have these sonography reports of your neighbor or at your home, uh, now or previous one, anyone you can select. And there are some other reports also, hemoglobin report, sonography report, x-ray reports. Don't throw them, try to study those, so that you will get some kind of information which is not even studied from previous 8 years. So if you have any doubt, try to ask those questions which are written on, and you can find out over Google. You can Google it. And i I think that will be the best uh, exercise for you to understand better about this sonography, x-ray report, and other pathology reports. That was my suggestion. So coming to back sonography, in sonography the main instrument is a probe. So this technique makes use of probe and a gel. So this is the probe. As we have seen previously, the gel is used to make a proper contact between the skin and the probe, so that the full capacity of the ultrasound can be utilized. So ultrasound totally it can be transmitted through the skin. So for that gel is used. The gel is applied on the skin, to the skin outside the internal organ to be studied. So for that you have to keep in mind whether is your internal organ which you are going to see. So the from outside you can put that gel, and probe is giving you a fantastic image. Now the color images are also obtained. Ultrasonic sounds are transmitted inside our body with the help of probe, and the sound will reflect from the internal organ, and it will gain the information which is collected by the probe and feed upon to the computer and generate a fantastic image of internal organ. As this method is painless, it is increasingly used in medical practice for correct diagnosis. So you can use that in it can be used for correct diagnosis. So we have studied what is echo. So the echo is a reflection of sound. For that, it is repetition of original sound because of the reflection of by some surface. Next, we have seen the calculations of echo. So the distance between the uh, distance total distance will be the 17.2 meters between the source of sound and the reflecting surface. Okay. Next, what is reverberation? Reverberation, it is also a sound waves which are getting reflected by the walls and the roof, and there is a multiplication of one single sound which is heard and which not be, it is continuously coming, and uh, it will increase the loudness only. So next we have seen the sonar. What is full form of sonar? Sonar is a sound navigation and ranging. Next we have seen the mechanism, how sound is sonar is working. The sonar is working with the help of two instruments. One is transmitter and another is receiver. So next we have seen the which is the technology which is used to make images of internal organs of our body, and that is the technology is called as a sonography. So the sonography, the function of probe, what is the function of probe? The probe is transmitting the ultrasonic sounds and receiving that sound, ultrasonic sound, and the computer will generate a picture image on the basis of this information. Thank you.
Ashok sir, you're over with your lecture.
Almost
Any evaluation part?
completed.
Okay, thank you, sir. Students, today we have completed all the 4 lectures. So tomorrow please join exactly at 8 o'clock. And tomorrow the first lecture will be Marathi. Thank you, students.